All right, guys, we're going to do some more. Today we're going to talk about exponents and what are the rules of exponents. Now, most of these I'm pretty sure you know, but I've already heard from you, some of you, that some of those skills need a little dusting off. So we're starting the dusting process now at the end of this year, and so maybe in July we won't have as much to do. Okay, so now, I'm going to start out with a simple problem. If you have x squared y to the fourth divided by, let me keep going, x to the negative third, y to the negative 1 divided by, sorry, that's just supposed to be an x, y cubed, y squared, x to the negative third. Okay? I said it's a pretty simple problem. I've used only numbers, no other letters. Okay? We're happy. Now, rules for multiplying. What do we do with our exponents when we multiply? We add the exponents. Correct? What about when we are dividing? We subtract. You're right. Exponents. I don't know why I put a T. What would that be a T? Exponents. Okay? So I personally go to all the X's, and I might even go to all the ones on the top and combine those, and then the ones on the bottom. We all agree that X, this one has a 1 there. It's not an X, Y together. They are still being multiplied together. So, at the top, I have x to the negative 1. I'm going to stay in the pink. I'm going to go this direction if that's okay. X to the negative 1. And on the bottom, I have an x to the negative 2, correct? Okay, so now what happens when I divide x to the negative 1 divided by x to the negative 2? We subtract exponents. I'm just going to say it right now. Nobody is too good to write out subtractions, because I know that if I get lost sometimes on subtracting negative minus negatives of negatives and negatives and more negatives, that it can be a little overwhelming. I write it out. Negative 1 minus negative 2. We add the opposite. So my x's become x to the first. All of those x's have just simplified to be x to the first power. Okay? Now, let's look at our y's. Y to the fourth, y to the negative 1, y cubed, and y to the fifth. Sorry, y squared. Already kind of simplified some. So I'm going to take my y's and go this way. On top, the 4 and the negative 1 become a y cubed, correct? And now I have a y to the fifth on the bottom. I know sometimes in Algebra 2, you took all the negatives to the bottom and all the positives to the top. It's up to you. Okay, there's lots of ways to do this. These are the simplest rules and will be the most helpful when we start adding a lot of extra stuff that we're fixing to do. So, y cubed divided by y to the fifth, 3 minus 5 is negative 2. So all of my y's have simplified to this. Now I know should have happened in Algebra 2, you never wanted negative exponents. Okay, so if I simplify this whole thing, it would be x, y to the negative 2. And a lot of times in Algebra 2, you didn't want negative exponents. So like we said just a second ago, we could take that negative 2 to the bottom. We say x divided by y squared. These are the same exact answers. They're just written a little different, depending on if you want negative exponents or if you don't, if you want a fraction. Okay, so here we go. I'll show you that in just a second. So if we have a problem such as y raised to the x plus 3 times y to the x divided by 2 minus 1 times z raised to the a. Yeah, I told you it wasn't always going to be so simple. Okay, Then we have divided by y to the x minus a divided by 2 times z raised to the x minus a divided by 3. Okay? Simplify. That's what things say. So we're still in the simplify umbrella of what we've been talking about. Okay? So, I personally, like we did last time, I took all the x's and I circled all their exponents. I'm going to do the same thing here. I'm going to look at all the y's and I'm going to simplify all of those together. Okay? So on the top, I'm going to add x plus 3 plus x over 2 minus 1. Okay? And then we would subtract the bottom. So then I'm just going to go ahead and write one long line out, if that's okay. X minus a over 2. And I like parentheses. I just do. Okay, now it's up to you how you want to solve. I start from the left and go to the right. Okay, I have some just numbers. Is it okay if I just combine those together? 3 minus 1 is going to be 2. Yes. Now, I have some x's. Oh, but they have different denominators when I want to add them together. Oh, it's okay. 2x over 2. Does everybody agree that's just x? Common denominator says plus x over 2, which is over here. I get 3x over 2 plus 2. Next, we're going to move on down to subtraction. So this was all of the addition. And now I need to subtract. Subtract x. Now when I pull these parentheses, I'm going to have some issues. Okay, because this is going to be a negative and it's going to distribute into both pieces. Don't forget that. So, and I'm going to pull my fraction apart so I can combine the x's with the other x's that I have. So minus x over 2 plus a over 2. Okay, because that negative of a negative. Now really these other parentheses I should not have had, but to show you that that's what we were doing. Okay, so now 3x over 2 plus 2 minus x over 2 plus a over 2. Let's simplify. There's really only one piece with two pieces with x in it that we can combine together. So I have a 3x over 2 minus x over 2 becomes 2x over 2, which is simply x. So now we have x plus 2 plus a over 2. Okay, that's probably as simple as I'm going to make it. It just is. Okay, but that is all y's exponent. Y raised to all of that. Okay? We still have another, basically half of a problem to do. We have the z's. Okay? So now let's take our z's. There's nothing to add. We're only subtracting a minus. Now I'm going to put parentheses because x minus a over 3, things are going to change. Okay? So I have a minus x over 3, remember this is going to distribute, to become a plus a over 3. We have an a and we have an a. Those are the only two pieces that we can combine that we should combine. But I need common denominators. I need a denominator of 3, so this will become 3a over 3 plus a over 3 becomes 4a over 3. And then our x is still over 3, so we can simply just leave that over 3. We could combine those all to have one thing over 3. That's probably what we're going to do. Now, y, should this be times z? It should. Z raised to the what? 4a minus x all over 3. We have simplified with some yucky exponents. Okay, but that's what we're going to do. We have one y, we have one z, and all of our exponents have been combined together into one exponent. That's how we would simplify that. Okay, let's look at another. I do need to refresh your brain a little bit in case you have forgotten. The square root of x. What is another way to write the square root of x? This is the one that I write down so often. I go back to this all the time. So square root, can you write it with x raised to something? Okay? And I go back and say, oh, it's the square root of x to the first. So that means it's going to be x to the 1/2. And I know that you saw this in Algebra 2, and maybe, I don't know, in physics, but this is a good piece to have. So if you have something like the square root or the cubed root of x to the 5th, could you rewrite this so it has an exponent that we can combine together? Okay, does that make sense? We want things to have exponents. This would really be x to the what? And then I go back to this and say, well, the 1 is on the top. It's the numerator in my fraction. So this will be x to the 5/3. Okay? Are we good? I hope so. I know you've got it. Here we go. Your problem will become, can you simplify x to the 3/4 times the square root of xy times x to the 1/2 times the cubed root of x to the 4th. Okay? We're going to remember our problems, and we're going to rewrite. Most of this we will, well, I won't say, we'll just rewrite really this piece and this piece when they are with the exponents, with the square roots. Now, what can you do when you have a multiplication under a square root? What's a square root? I'm going to go back to my thought bubble here. What's the square root of 4 times 100? I don't know, square root of 400, right? Can you multiply those together? Or could you break it apart and say the square root of 4 times the square root of 100? Yes, you can. So I'm going to do that right here. That really is the square root of x times the square root of y. Okay, you can break that apart. So, as I'm doing that, I'm going to go ahead and rewrite. So I've got an x to the 3/4 times x to the 1/2, which is right here. And then I have a y to the 1/2, which I'm going to take to the end, so I don't want to write it. So I'm going to bring this one, x to the 1/2. I'm going to go ahead and write my y to the 1/2 out here, because there's nothing really I'm going to do with that. What about this, the cubed root of x to the 4th? I've got to go back and look at this example. All right, so it's going to be x to the 4/3. Okay, so that is my problem. So now we've got to combine. So all of these are being multiplied together. There's no dividing. So it's just really adding fractions. How do we add 3/4 plus 1/2 plus 1/2 plus 4/3? Yep, common denominators. What's my common denominator in all of this? That 3 right there throws things for a loop. So I think it's going to have to be 12, right? Yeah. 12. So I've got 6/12, 6/12. Then I have to think 4 goes in 12. That's 9/12 and 16/12. So I need to add all of these. My brain has stopped working. 12 plus 9 is 21 plus 16 is 37. So we're going to have x to the 37/12 and a y to the 1/2 because it was out there alone. Or y. Should have made one up to go out there with it. And you're done. You have one x raised to one exponent. You have one y raised to one exponent. Okay? Are you ready? We're just going to have 1 or 2 problems. Should I go through one more of those? Does it matter? I think you probably have it. All right. So here's your 3 problems for today. Problems with exponents. Here's number 1. Number 1 is going to be x raised to the a, y raised to the a plus b, divided by x raised to the negative a over 2, y to the b minus 1. Okay? Your second problem is going to be m raised to the x plus 2 times b raised to the x minus 2 divided by m raised to the 2x divided by 3, b raised to the negative 3x over 2. And your third problem will simply be the square root of xy times x to the 2/3 times y to the negative 3/2. That's it. 3 problems, working on exponents, simplifying things, and we're done for a little bit. You guys, I'm sure, are rocking it. We will talk to you later. Bye.